machine learning and the advancements are enabling us to have problems that we never had before, and we need to find a way to solve them.
Hello, welcome back to the Mastering Complexity podcast. I'm your host, Owen McCall, joined today by Silvana Albert, PhD in Machine Learning and part of the Big Data Technologies team here at swissQuant. Silvana, thanks so much for being here.
Thank you for having me.
It's my pleasure, really. Silvana, I'm hoping you can help me out. I'm going to do my best in this discussion to keep up. There's a lot of terms to keep in mind. I'm really going to try here, but maybe we can start simply. Can you tell me a little bit about the history of artificial intelligence, of machine learning, where it all began, and maybe just a few points along the way that people should really know that stick out and really have led to the advancement of the space and where we are today?
Yes, so humans have been thinking about artificial intelligence and replicating a human brain for pretty much all our recorded existence. In the 1950s, there was the first formal attempt to devise a test of what it would mean, and that was the famous Turing test.
The test of artificial intelligence, whereby, if I remember correctly, humans wouldn't be able to tell if they were speaking to another human or a machine.
Yes, but the term itself, artificial intelligence, was coined only in 1956. Then there were a lot of advancements in different fields. You had robotics, you had the way of playing the game of chess and winning. That was a historical point for artificial intelligence. Progress was made also on neural networks. In the 70s, we had these expert systems where humans would pre-program knowledge in, and they were able to make decisions. So there were a lot of smaller steps down the way, but it experienced this huge growth since the 2000s, especially with the big data revolution. We are collecting so much data, and this way artificial intelligence really had its place to shine. Yes, and there are, the history is still in the making. Of course, there were multiple places down the line, but only now we are looking into quantum computing integrated with machine learning. We are looking into this explainable AI. We are setting up the framework for regulation and how we can use it in an ethical way. So we still have some challenges down the line, but I do believe the history is in the making.
History's in the making, the time is now. Very cool. And so if I understand correctly, machine learning can really be thought of as a subset under the general umbrella of artificial intelligence. And you're going to have to help me out here, but there's a few different types of machine learning. There's supervised machine learning and unsupervised machine learning. And that's about as much as I know.
And reinforcement.
And reinforcement. Okay, so three. Unsupervised,
yes.
Supervised, and reinforcement learning.
Yes.
Can you give me just the elevator pitch of each of these sectors? What is supervised machine learning?
Supervised, it means that you are dealing with labeled data. You know from the beginning what the target output should be, and you can check that your model learned that because it's able to produce the same kind of target output. So labeled data, supervised learning.
All right. Let's talk a little bit about unsupervised learning. In a nutshell, what do people need to know about this?
Supervised learning is very useful when you are trying to uncover hidden patterns inside the data and you don't have labels. So it's the opposite of supervised learning.
Okay, so you provide the algorithm with a massive data set and you say, have fun with it. Let's see what you can do.
Yes, something like this. But even in unsupervised learning, there are ways to test what the output. So you will not just believe its word that it works. You will have, for example, if you're doing this clustering, you have a metric called silhouette score to make sure that the clusters are separated enough. Clustering means grouping of data points that are more similar than others.
I see. And that's important for all kinds of applications. Okay.
Yes.
And the third term we were talking about was reinforcement learning. Now, is this the classic carrot and the stick? How does that work?
That's exactly it. It's the carrot and the stick. Basically, you have this, you can have multiple strategies, the algorithm, to explore a space or to find the solution. And when it's getting close, you can give a reward. When it's not good, it gets a penalty. So it interacts with an agent, whether it is a human or another system. It gets some kind of feedback and it incorporates it into its further the behavior.
Okay, and ostensibly this will sort of hone the strategy in order to reach a desired output, but you deploy it as the system is learning reinforcement. Okay, I guess that makes a lot of sense. Thank you. Now, what about if we're trying to solve a problem? I guess there would be applications where an unsupervised approach would work, maybe in another one a supervised approach. What about mixing them together? Do you have any examples where we could see something like this?
It depends on the problem we have to solve, and it depends on the data that's available. If from the start you have labeled data and you can make use of it using supervised learning, maybe you can use unsupervised learning in the pre-processing steps. Maybe you're trying to see what's the best way to clean that data and prepare it from the training, and so on. So it really, most of the problems are not black and white, just do that. Most of the problems have real world problems, have all kinds of constraints.
They're messy.
And we have to find ways to work around it. So one example I have is in our research we had to do this imputation because we had so many missing values. But if you see this giant matrix, you cannot just put 0 when there is no value, because 0 would mean that's the minimum value, and you just did
You'll
not
skew
record
the whole data set.
Exactly. You did not record the value there. It's not that you saw it and it was a true 0. So then you can have a multitude of unsupervised learning algorithms to try to see what would be the best value to put in there based on what's around it. Maybe it's a time point. If it's a time series, maybe you know that point to be from a given category of the data, so you're trying to average values from the similar category. So you can use unsupervised learning to make sure you can fix this problem and prepare the data set for the next learning stage.
I see. Okay, very cool. Now, you talked about we're sort of in the golden age of machine learning, of artificial intelligence right now. I'm curious, in your perspective, we talked about hardware a little bit. Where do you see the bottleneck or the interferences for future advancement in this field? Is it a hardware restriction? Is it expertise? Where's the bottleneck?
I think now we, at least from what I worked on this personalized medicine and molecular insights, it's no longer the hardware. Of course, we need better instruments to capture the data, but even after we have it, it's this expert knowledge, because we are comparing apples and oranges and we don't know yet. So for example, if I'm integrating a transcriptomics data, so from the RNA with the protein data and with the DNA data, nobody has done that before. How do you know how it works? You're comparing some kind of thresholds in one thing. Everybody's measuring different things, and you're trying to get some insights from the joint omics. So it's machine learning, and the advancements are enabling us to have problems that we never had before, and we need to find a way to solve them.
Modern problems require modern solutions.
Exactly.
We talked a lot about your work in the healthcare sector. Let's bring it back to, let's talk about finance a little bit. Can you tell me a little bit about how machine learning is being used here at SwissQuant?
Yes, so I am a part of the big data team, and we had multiple applications of it. We have our own anti-money laundering solution, and we are trying to do fraud detection. Here, the goal was to build an explainable machine learning solution to make sure that we can know what the decisions were made and why something was flagged and needed human interaction or not. Because, you have huge amounts of transactions, and if every single one of them requires attention, there is no way of moving forward. So such a system that only flags what's relevant is very useful, and that's why we needed the rules to be explainable and also to be able to generate new rules as we go. And that was one of the applications. Also, inside the team, we worked on this predicting bank stress using CDS scores. And
that's credit default swap scores, CDS scores,
yes,
right? Okay,
yes.
Cool. So using credit default swaps to predict, what was it, bank vulnerability or? Okay.
Yes, yes, exactly. And we had some applications of natural language processing on ESG scoring of illiquid assets. Basically, when we're trying to score real estate, you have these huge energy certificate documents. They are all in different format, and you're trying to make sense out of them and extract the relevant values. in order to give an ESG rating. And there we used the image recognition and natural language processing, and we extracted those values in such a fashion. But this is just the beginning. In the future, we want to include these techniques in all of our products, depending where we see a need, because they can elevate our services.
Okay, well, let's get a little more personal then, if you don't mind. Why don't you talk to me a little bit about how you got into the field and what those steps look like?
Yes, so I had my bachelor in computer science, and I was already working as a software developer. My master's culminated with this big data expansion, 2015, something like that. And
the timing was right.
Yes, the timing was right for me to do my master's thesis in big data. I was very interested in genetics and genomics. So I did a combination of big data and genomics for my master's, but then very quickly I realized that the next step is machine learning, because when you have big data, you need a way to make sense out of it, and machine learning is the way to do it. So for my PhD was focused on applying machine learning models and principles. So I did not invent a new type of neural network. I was just applying existing things in order to get additional insights and finding new patterns into proteomics data. And then I continued working as a postdoc here at ETH, where we analyzed data from cancer patients. I was a part of this great project called the Tumor Profiler. It was a pioneering project in Switzerland. They were taking biopsies from terminal cancer patients, and they were splitting it. And we were 10 nodes, 10 specialties that analyzed the same data, and then we tried to integrate it back together and have some insights for the clinical board.
So it sounds like a multidisciplinary approach, trying to create a sort of a holistic view on these things. Okay, yes. Very interesting. And were there a few things that stuck out to you when you think back on your postdoc work or even your PhD? I mean, you mentioned that this was really a big time for advancement and change in the field itself. Are there a few things that come to mind when you think about sort of big discoveries along your journey itself? Were there some aha moments that you remember?
For me, it was very clear when this AlphaFold project came. During my PhD, I also worked on this protein folding problem. Basically, you're trying to predict how the protein will fold and look like in the end. It sounds simple, but it was a challenge in the field for many, many, many years. And then it was fixed with this AlphaFold algorithm. That was it was a major point. There was always the research side of artificial intelligence, but it really got some traction once the big companies started investing in it. So once the tech giants came into play, we can already see that it's advancing way more than before.
Right, and that was going to be my next question, actually. So you're talking about around the 2015 mark, maybe up to 2018. What do you see as some of the major steps outside of this private sector investment? What are some of the major advancements that you see in this market since that time, since 2018 or so? What are the big changes in your view?
The critical period was until then, actually, the early 2010s, when we had this big data. We are collecting so much data. Every 2 years, we doubled the data that was ever collected. So this was one of the reasons why it exploded. Another reason is advancements in hardware, because now we have these GPUs that are able to process data way faster than before. Also advancements in the cloud storage that you can really scale. In the computer science domain, there was always this culture of open source, and it's really democratized. Anybody can start learning, and everybody is contributing, and it's one of the things I love about it. You find so many tutorials, and people come together in a way that it's truly promoting fast advancements.
And wasn't that, if I'm not mistaken, you talk about AlphaFold, if I remember correctly just from headlines, one of the breakthroughs was when they exactly democratized access to these data sets, and in a decentralized way across the world, people were participating in this protein folding demo. Am I correct crazy about remembering this?
I'm not I know that it was a lot of problems for a lot of labs that were actively working on this, and their funding got stopped because of it. Of course, they are making all of this public, and it's good that the data sets and everybody can use them and make advances with them. So now, even if we can all learn these algorithms, there is still power for those who collect our data, because the data is not all available, especially in personalized medicine and what we are seeing for cancer research. You have so much regulation of the data you can collect, privacy protection. You cannot share it. You cannot even analyze it in any way you want. You have to analyze it only in the way it was agreed to. So in a country like Switzerland, where we have so much regulation, it's a small country, not so many sick people, it's very hard to have advances. That's great, of course, but for science...
because if I understand what you're saying, you need these massive data sets in order to really parse through and okay, that makes a lot of sense. So I guess there'd be an advantage in some ways in a regulatory regime or a country where there's less focus on data protection. That would, in this case, be a bit of an advantage, it sounds like.
Yes, in these cases, yes, but we need to consider always with this artificial intelligence, there is this saying, just because we can, it doesn't mean we should. So at this point, this artificial intelligence field has the capability of interfering so much with our lives, helping us in ways never foreseen before, but also causing a lot of damage. That's why we have to be very careful to the biases that were in the data that was trained, to make sure that there is equality there and that nobody experiences discrimination out of it. We need to ensure basic safety. You know about these deep fakes that in theory I could
Absolutely.
say, somebody could replicate your voice and your appearance and make you say something that you did not say.
Yeah, you can so easily right now with a few clicks, you can train your own voice AI. You feed it, you read a couple of sentences, and in the background it spits out a whole operable model that anyone could use ostensibly.
Yes, so you can imagine how the vulnerable sectors might be affected by it if, in case somebody wants to use that for bad, like tricking an old grandma into sending all her money because she thinks you're her grandson.
Right. Scam phone calls 2.0. Absolutely. It's getting scary. So then I'm curious. Ethics is obviously a major consideration here, or at least it should be. How was it in your experience in the research world? How was ethics of what you were working on? How was that painted? How was this outlined? What was the focus like there?
So we all had to be certified. We had to do this data trainings to make sure that we understand what we are dealing with. Also, we had a lot of requirements in terms of protocol and hardware, and where we can deposit the data, where we can analyze it, everything like that. Anything that can trace back to a patient is not okay, so our data was already anonymized when we got it. When it comes to clinical decision support, we were not responsible for the decisions. We were just helping with some insight, but it was the goal of the study was to inform and bring additional information, but not do any kind of recommendation of treatment. So one of the notes that was involved, they were doing this drug tests. So in theory, if you are a terminal cancer patient, you don't have the time to try 125 drugs or everything that's available. But with the help of this technology and with the help of clustering, maybe you are assigned to a group where you know that it worked for the others, and this increases the chances of that drug also working for you. But it's not enough to base this decision only on that grouping. They had also the traditional medical approaches to make that suggestion.
Gotcha. So it was a human in the loop, kind of hand in hand, an augmentation,
yes,
some might say, of decision making. Okay. Now, as an expert in this field, if you're able to look ahead 5 or 10 years, are there some use cases that really excite you that you think will have a massive positive impact on the world?
For me, it's the advancements in healthcare that are the most exciting. Let's talk, for example, about the field of radiology. There it's obvious how much machine learning has helped as a professional, as a medical professional. you can see a limited amount of CT scans or MRIs or what do I know. But if you harness the power of machine learning, you can gather insights out of everything that has been recorded, not just what you had experience with before. So I'm happy about the progress we made in healthcare, especially in this omics field. But we know how much we still need to go, because it's just so complex. This is the only way to solve it, through machine learning, and yet it's still so complex that it will take us some more time from now on.
Is there anything that scares you?
There is this book, The Rise of Robots. So it's, I think the subtitle is something like The Threat of Mass Unemployment or something like that. I mean, of course, now the jobs that are being threatened are these white-collar jobs. Business analysts, lawyers, I don't know. So I think we will experience a transition where there will be new jobs in order to integrate artificial intelligence into our daily lives. But how the future will look like after that is very, very hard to say. It could be this utopia where we have so much free time for our hobbies and the technology is generating more wealth for all of us. But it really scares me in case it will not be equally distributed, this wealth, and we would have a lot of people that no longer have a job. But this is really...
Right. And it sort of feels like that's always the promise with every industrial revolution. Yeah. Expanded recreational time. And so far, it hasn't really been the case, but we can still cross our fingers for the future. Yes. Okay, very cool. Silvana, it's been really exciting. I've done my best to keep up. I think you've done a great job breaking these things down for the average person like myself. So thank you so much for joining us. There's a lot that's been done. There's a lot that's still to happen, and it's really exciting to speak to an expert like you, someone that's really in the mix. And what I find particularly interesting is that you've sort of seen machine learning and artificial intelligence in a number of different sectors: healthcare, finance, it goes on and on. Thanks again for joining us.
Thank you so much for having me. It was a pleasure. And yeah, I think you caught up quite nicely, and you know a lot now. You can be also a co-expert.
Ooh, okay. Maybe we switch chairs next time.
Yes, sounds good. I want the gray one.
Thank you.